Ladies and gentlemen, we would like to welcome you all to All Pakistan Tech and Art Festival 2021 organized by GCU-ACM Student Chapter, Lahore. The title of today's is for on the role of artificial intelligence and machine learning in cybersecurity. The relentless pursuit of pioneering in today's competitive advancements in the communication and communication technologies have created double-edged swords. On one hand, these advancements enabled new futuristic applications and services such as, but not limited to, Internet of Things, Industry 4.0, smart finance, health, agriculture, and transportation. But on the other hand, it increased the threat landscape. The connectivity of everything to the internet, in principle, lowered the cyber attackers, which is evident from the intensity and the number of cyber attacks during the last couple of decades. Traditionally, cryptography is considered as the first line of defense in security. However, cryptography alone may not be able to protect against sophisticated cyber attacks. Recently, artificial intelligence and its different forms, including machine learning and deep learning, which are both abbreviated as ML and DL respectively, have been leveraged to address the cybersecurity challenges and volume counter the notorious attacks. Another prospective reason for using ML and DL in security solutions is is the volume, velocity, veracity, and variety of data produced by the futuristic network paradigms such as Internet of Things, which is abbreviated as IoT, and ML, and of course DL methods that could be used to learn about different methods, draw patterns, and predict future occurring of certain events. Furthermore, ML and DL offer a rich set of features that could be leveraged in solving security challenges in cyberspace. This talk will cover the role of AI, more precisely ML and DL in cybersecurity. Will abstractly cover the features of ML and DL for different aspects of network and cybersecurity and argue on the rationale of using ML and DL to address cybersecurity problems. As a use case, we'll discuss IoT and some attack scenarios. We'll then discuss whether we should use AI for security or security for AI. Towards the end of this talk, we'll shed some light on the vulnerabilities of AI mechanisms and the use of AI in adversarial setting for providing security-related solutions. Furthermore, we will talk about open research challenges in this direction. Now, moving to our speaker's introduction, our today's guest is going to be Dr. Rasheed Hussain. Our guest has received his BS Engineering degree in Computer Software Engineering from University of Engineering and Technology, Peshawar, Pakistan in 2007, MS and PhD degrees in Computer Science and Engineering from Hanyang University, South Korea in 2010 and 2015, respectively. He worked as a postdoctoral fellow at Hanyang University, South Korea from March 2015 to August 2015. He also worked as a guest researcher and consultant at the University of Amsterdam, abbreviated as UVA, the Netherlands from September 2015 till May 2016, and as assistant professor at Innopolis University, Innopolis, Russia, from June 2016 till December 2018. Currently, he is an associate professor and the director of the Institute of Information Security and Cyber Physical Systems at Innopolis University, Innopolis, Russia. He is also the head of the Networks and Blockchain Lab at Innopolis University and serves as an ACM Distinguished Speaker. Without further ado, I would like to hand over this webinar to our respected guest. You may have the stage now, sir.
Thank you so much for the introduction. I'm really delighted and I feel an honor to be today with you and share my thoughts on the topic. Let me share my screen. Okay. Uh, can you please confirm that you can see my screen?
Yes, sir, we can see your screen.
Okay, great. So the talk for today is friend or foe, the role of artificial intelligence and machine learning in cybersecurity. I'll be sharing my thoughts with you on the topic and my personal experiences and some research background and these kind of topics I'll be covering in this talk. The agenda for today is that I will talk about cybersecurity, the way of thinking, how do we think or how people think about cybersecurity, what is innovation versus security, what is the relationship between them, what is the attacker mindset, what is in the mind of an attacker when we listen or when we hear about different cyber attacks on networks or infrastructures, sophistications in threats, cyber threats, and the role of machine learning and artificial intelligence in general in cybersecurity. And then I'll cover something about adversarial machine learning as well. Before moving forward to the actual talk, I would like to thank ACM for providing me with this opportunity to volunteer for these kind of talks. And it's a pleasure to be representing ACM in such events and in such scenarios. I think the host already talked about me, my background, what exactly I do, and where did I come from, and all these kind of information or shared with you already. So I will not waste my time on these. And I will move directly towards the start of the talk. Before I start, if there's any question, please raise your hand because I want to make it more interactive. We will have some time for question and answer at the end of this talk, but if there's something that cannot wait or you really want to ask right away, please raise your hand and then the host will enable you to unmute your microphone and then you can ask. Or we can take a short break as well during the talk because it will be a bit longer than usually it is because I wanted to cover most of the things that are necessary and that are beneficial for the student community. As I was told, most of the audience will be students and senior students who will be looking for basics, and this talk will, I hope, will be beneficial for those kind of students as well. Okay, so the first and foremost important question is, what is security? Now, this is a very broad question that one can ask. There are different answers to that. There's no single answer to this question, what is security or what is cybersecurity? In order to answer this question, you have to look at the context. If you're in academia, then the answer would be different. If you're in industry, the answer would be different. From academic perspective, we have different answers, different similar answers to this question about security. So whenever we talk about security, we think about authentication, we think about confidentiality, we think about integrity, we think about privacy and availability. And there is a very specific and well-known triad, which we call CIA, confidentiality, integrity, and availability. So all your security requirements, whatever you think of, they will come under the umbrella of one of these aspects in cybersecurity. And these are not the only definitions or only prospects of cybersecurity, but there are more. But whatever you take, it will come under one of these. So this is academician perspective of cybersecurity. If we go to industry, then the definition changed a little bit. Whenever you ask this question about cybersecurity in industry, they will be taking this as a definition where it will cover different kind of attacks. For example, DDoS, different kind of that have as a result of certain cyber attacks. They will be thinking about safety, they'll be thinking about hacking, and the bigger picture, which is revenue of that industry. These are the two sides of one picture where we can think of cybersecurity from different perspectives. As a layman who has nothing to do with either. Whenever we talk about security, the first thing comes to mind, even in computer science or in any engineering field or any other science field, when we talk about cybersecurity, the first thing comes to mind is what? It's hacking or is stealing passwords or those kind of things. Yes, it is true, but it is not the whole story. It's broader than that. Okay, so we looked at the definition of cybersecurity, but there different kind of thinkings actually. One is the old way of thinking, and another one is the new or evolved way of thinking. In the cybersecurity doctrine, the old thinking is that we should be protecting the information, the content, and the network in which these content or information are shared. And we have to isolate and protect the network from these kind of attacks. So this is the old thinking. Well, you might be thinking that it is still valid. Yes, it is still valid, but the priorities and the environments have changed, and they have changed a lot. So when we talk about evolved thinking, we are talking about not protecting the network or the content, but we're talking about protecting the services and applications or mission for that matter. And then we think about operating through failures. It means that we accept failure may happen or may occur, but we have to go through that. And we have to make sure, even if there's a failure, our network is still up and running. Our services are still up and running. Imagine a bank that is providing you with the services and something happens, God forbid. And would you as a customer like to stop receiving services from the bank? No, you'll be worried sick. So you will have to think that the bank should do something for the customer, that even if there's an attack or even if there's a failure, it should be operating, right? So in the evolved thinking, we have to think the services and the applications into account. Not only the services and applications, but even their context as well. So what is context? We will talk about that in a moment. Okay, so if we talk about the nuts and bolts or the bread and butter for cybersecurity, then we definitely have to think about trade-offs. I wish it was that simple, which is not. Whenever we talk about different aspects of security, they're usually fighting with each other. For example, if you think about authentication, authentication means that you have to prove who you say you are, right? And then there's another very strict security requirement, which is privacy. Means that you never want to reveal your identity, or you never want to reveal your location in certain scenarios. Okay, so then there are trade-offs that we have to talk about. There should be certain middle ground between these two. And we will have to look into solutions that cut both the corners for the security requirements and for the privacy requirements. And I give you just two examples, but there could be more. So these are conflicting security requirements that we have to think about. In the nutshell, there should be trade-offs or there should be compromise at each side. And application context, it is once again essential in this case as well. Imagine a banking application, okay, or a banking service. You as a customer have different context, means that you as a customer can only see your account details, your current amount in your account, and so forth. You will not be able to edit that, right? So that is what a context means. And if you think about an IoT application, there could be different contexts. So the application services that are given to consumer are different than application services that are given to pathologist, to doctor, to surgeon, and so forth, or the manager. So these are the contexts that should be taken into account as well. Well, from a general perspective, privacy is extremely important and security is also important. And these two usually, in most of the cases, contradict each other. So we have to think about um, certain solutions that are meeting the goals for both of these, not the one, but both of these. Because in 21st century today, and in the recent years as well, privacy laws have been very strict. You might have heard of GDPR, General Data Protection Regulation, which is already implemented in Europe, which really tries to protect user data. So no corporate, no enterprise, no company can use your data without your consent. And you have the choice to tell them to delete your data. Or you have the choice, you have the right to be forgotten. And this is in the law. They have to implement these things. With that in mind, the implementation of such mechanisms become even more challenging. So we have to think about that as well. Now, on one hand, we have productivity, and on the other hand, we have security. In the productivity side, people usually don't care for security. Why? Because in today's business world, everybody's running after being pioneer. They want to get their product out in the market without even thinking about the repercussions that could occur because of some cybersecurity threats or some attacks and so forth. So the ideology is to just build it and cash the benefits out of it, and then you can just wait for some attack to be happened or your next generation can secure. So don't worry, as long as you're earning money on that. Well, it's not 100% true, but in most of the cases. And on the other hand, if you are talking about the security specialists or people who are worried about security, what they do is that they do not build a service, they do not build a system. And what they do is that they do it with taking security into account. Okay, and they test it before they bring it to the market from security and privacy perspective and so forth. But the right hand side of this line is time consuming, number one. It's expensive, number two. It's annoying, number three. And it's extremely difficult to convince people with, especially if you're working in a company. It will be very hard to convince your managers or upper management to these kind of things. It is from practice and it is from experience that it's extremely hard to do such thing. The solution is to find somewhere the middle ground. And the bad news is that we don't know where that middle ground is. But there is a middle ground somewhere where both the entities should be agreed upon. Okay. There's a dilemma that have a fair amount of data, and we also have sophisticated attacks, and we have this mindset of attackers as well. And all these four aspects, they result in a very hard to solve dilemma. These mammoth resources and sheer amount of data that can be considered in any setup. Consider an autonomous car, driverless car, and consider an IoT system, Internet of Things, smart home system, the amount of data it creates, and so forth. We will see in a moment some of the statistics from real world, and that will give you an idea about how large these systems are. So if we consider a volume of data back from 2017, then every minute of the day, back in, keep in mind, it's 2017, users were uploading 48 hours of video, and 217 new users were using mobile web, and email users, and Google users, and so many other users. So you can imagine the amount of data that was generated every minute of the day. So in 2017, if we chop it down to the most famous or most well-known applications, then 455,000 new tweets were tweeted every minute. Okay, and 400 hours of video was uploaded to YouTube. It's easy to say these things with words, but just imagine the colossal amount of resources that it takes, or the storage that it takes, and so forth. So if you have this scale of data and communication, you can imagine what could happen to these networks. Let's go to 2019. Okay, in 2019, back in 2019, 2 years ago, it was expected that 463 exabytes of data will be created by 2025. And we are in 2021 now. I think it will surpass this amount, because this is not that much great of an amount if we see the volume of data that is generated today. So the point is that we have huge amounts of data, which takes a lot of resources, both in computation and communication, and we have to think about doing something with it. How about 2020? If we take 1 minute from internet in 2020, there are about 1.3 million logins to Facebook. There are 4.1 million search queries on Google. There are 764,000 hours of videos that are watched on Netflix, and you can go on. Just imagine once more. You can compare the year 2017 and 2020. It's constantly growing, and it's not going to stop. So we have to take all these factors and so first one is militaries. They're creating, for example, cyber weapons, robot soldiers. Once it was science fiction, and it's not anymore. We have them actually. Second one is governments, to control people, to establish some hegemony and see what the citizens are doing for both valid reasons, actually, for national security and these kind of things. And third one are the corporations, to produce or to establish monopolies, to go into competitions, because in corporate world, they think that is I mean, everything is fair in war for them to win businesses and so forth. That is why they do these kind of stuff. And we have hackers who steal information and resources for whatever reason, to earn money or to earn fame or to do they want. There are some doomsayers who as well. There's some psychopaths. If you study the of cyber attacks and these kind of environments in which they launch these attacks, you will be surprised to see that people think their name should be written in the history because they brought something down. And they're criminals, of course, they do it for criminal reasons, or just because it is fun for them. People do it. And we also have these, if we talk about hackers, we have ethical hacking as well, where hacking is permitted to make the system even more secure. So once mindsets in mind, then you have to bring the solution to a level uh, which will be used against one of these kind of attackers. So what is the relationship between innovation? We have mobile phones in our hand that could do whatever we wanted with, which wouldn't be even possible with a high-end computer 10 years ago or 20 years ago. Imagine year 2000. It was not possible to, do a lot of things that we are currently doing on our fingertips, right? Yes, it is very good, but you have to think and you have to realize that these kind of innovations are also increasing the threat landscape, because the more data you have, the more vulnerable you are, right? And the more communication you do, there is a chance that it will fall into the wrong hands, unless and until you have very sophisticated mechanism to use it for. Second one is complexity. So these systems that we are talking about, Internet of Things, for example, autonomous car, or any other, let's suppose, industry, they're very complex. They're not. If you take a SCADA system, which is an industrial control system, they're extremely complex. The complexity adds more to the vulnerabilities. Being complex doesn't mean that it will not be vulnerable to certain kind of attacks. So if you're trying to secure it, you might have missed some points that will give to the attackers. And then comes the demands of the citizens. Well, we want everything with our applications, right from music application, you net demands of citizens, and then on top of that, businesses, it's increasing, and it's increasing in a way that has some contradictions with the requirements of the security and privacy. So you have to think about that as well. On top of that, there then sophisticated. It is in the category of sophisticated attacks, but it could be launched in a very simple way or in a very sophisticated way. If we look at the statistics for malware, in 2018, there were 844.35 million malware, okay? And if we look at it from the perspective of per month, then it was almost increasing every month. And then you can see the new malware where what we call zero-day malware. Zero-day malware is some kind of malicious code that was not found before, and it is unknown. So it's completely new. In 1 month, for example, if you take October 2018, there were 10.99 million new malware that were found. And the same, just imagine they are in millions. They're not in tens of thousands, they're in millions. So how do you cast that? Well, if you have a security mechanism for malware that was back in 2017, do you think it will be usable, or it could be used to counter the attack through these 8.23 millions? No. Well, if you get lucky, yes, but in most of the cases, no. That might not be usable here. So what do you do for 8.23 million new malware? Do you uh, do you develop 8.23 million new solutions for these malware, these new malware? No, that would not be a very wise idea. So you can see the pattern that we need to have something sophisticated that takes the previous history into account and do something that could solve the new problems as well. Another real world scenario, I'm not sure if you have heard about Mirai. This is a Korean word, Mirai. Mirai means future. Uh, Mirai DDoS botnet, it was back, I think, in 2016, and it brought down the entire internet. And it literally crippled the internet. Of course, temporarily, it was solved. The problem was solved actually, but it shook the entire internet. And you would be surprised to know that this attack was launched by an undergraduate student in the United States. So what he did is that he found out the CCTV cameras, IP cameras, not IPTV, IP cameras, which were not secure. And what he did is he used those cameras to launch DDoS attack on uh, these services, OVH and Dyn. These are the DNS services. These are the DNS services that provide the DNS functionalities to other corporate worlds, almost entire internet. What if we launch 600 Gbps or 1 terabits per second one terabyte amount of is what I think of. So what do you do in this case then? Here is actually here's the map where he found the insecure IP cameras and launched attack from all these places on one site, which was in UK. So it didn't took him a long time, or it didn't took him infrastructure to launch this kind of attack, but still it happened. Another real world example, you might have heard of ransomware. Okay. Have you or somebody got affected with WannaCry? So this is one of the ransomware where the attackers, what they do is that they get hold of your computer, they encrypt your everything, and you see this screen. They tell you to send me this much amount of money, otherwise your data is gone. Because they encrypt it and send you the key only when you send them the money that they ransom that they want you for. It is mostly in the form of Bitcoin. This is another scary thing that you can think of. And ransomware in cybersecurity is actually a huge business. By business I mean business on the other way, because it makes the loss of money so easy that people can lose, or companies can lose billions of dollars actually. So here you can see that from 2011 till 2017 there are tons of ransomwares that were launched on different companies or individuals to ask for money. So what about automation? If we make everything automatic, will it help? It will help, But the problem is that if we have 100 steps, the attackers or adversary might have 101 steps. They might be one step ahead of us. Okay. So more than 9 million instances of malware are seen per month. As I told you before, you cannot catch up with solution for these malwares. So you have to look into automation, right? And then the problem is that with these new set of malwares, there's an increase in fileless attacks as well. Fileless attacks means that, well, you have the malware or you have the insecure code in your system, and you don't have to do anything to, activate it. It activates itself, and it is insanely scary. So before we were told, or you were told, that if you receive an email with attachment, if you're not sure, don't open it because it might be malware. But that's not the whole story, because they're fileless attacks. It means that you don't have to download something. The moment you receive it, it could be dormant, and it could come back to life and do whatever it wants to do. The example is, I think I missed it here. The example is Stuxnet. You might have heard of Stuxnet. Stuxnet is a very sophisticated code that was used to sabotage the atomic facility in a country. And it was real. It is extremely, extremely intelligent code and intelligent malware. So by all these, this is the precursor for a new methodology or a new mechanism to fight against these kinds of attacks. Okay, we will start the second part of it, but before that, if you have any question, please ask now. We'll take a 2 minutes break as well. If there's any question, please ask me.
Assalamu alaikum, sir.
Wa alaikum salam.
Sir, as we know that machine learning becoming the most trending field of the 21st century. Sir, my question is that with the help of machine learning, it is possible to detect cyber attacks before they happen in an efficient manner, like ransomware.
Yes, we will talk about it. Right, it's a very good question actually. We will talk about it in a moment, but the simple answer is yes, and it has to do with behavior. If everything is coming new to you and you cannot solve it individually, then you have to look into patterns. Okay, I mean, you cannot do it individually for every instance of it, but you have to look into patterns. An example is, you have a bank account, or you are a corporate bank, and you're a security head or security manager or security analyst or whatever, and there's an account on which, on average, there's a transaction of, let's say, $200 per day, around about $200. And suddenly there is a $1 million transaction, for example. It might not be a bad thing to happen, but it's definitely is an anomaly or an outlier. So it will give you a hint to look into that. And these kind of incidents will let you to look more detailed scenario and to look into the details of these kind of transactions and so forth. Okay, so our second half is to talk a little bit about artificial intelligence and machine learning. Well, machine learning and artificial intelligence are huge fields. If there's any other question, please ask. Otherwise, I'll move on. Okay. So the difference between artificial intelligence and machine learning. Well, machine learning is under the umbrella of artificial intelligence anyways, but if we really want to see the difference, then the machine learning is capability of learning without explicitly programming, And artificial intelligence is the capability of imitating the human behavior. We know that humans are intelligent, they use their brain. So in order to imitate this kind of behavior, the system that we use is called artificial intelligence. So there are certain steps in this process. The very, very first step is learning. So you have to learn through data, through experience, through whatever. Doesn't matter. But you have to learn. This that based on the learned environment or learned features or learned anything that you can name of, you have to perceive, get this. Once you have learning and you have perception, then you are able to decide on something. Once you can be autonomous. Means that you're autonomous in making decisions. So the first part is related to learning, which is done by machine learning algorithms. And the second part, which is here, is done through artificial intelligence, which is perception, decision, and autonomy. So what is machine learning? Machine learning is just automating automation. It might seem weird, but it boils down to automating the automation itself. And by machine learning, what we do is that we're getting computers to program themselves. We don't program them, and we let them program themselves as well. But the problem is that writing software is always the bottleneck, because we as a human being can do a lot of mistakes, of course. So because of this reason, what we do is that let the data do the work instead. So that is why automating the entire automation is extremely important, and it's the building block for machine learning. If we simplify it a little bit more, what exactly machine learning is? So in traditional programming that you have been doing through your student life, is that you have a computer and you have a program that you have written in C, let's say, add two numbers, or C++, or Java, or Python, or whatever. You wrote this program and you give it the data, and it produces you the output. This is the traditional programming. But if you switch to machine learning, it means that you give the data as an input to computer, and it does is that it, keep in mind, it's not the literal meaning of a program, but it could be a model, or it could be an output, it could be a prediction, it could be a decision. Okay? So this is the main difference between a traditional programming and the machine learning. If we compare it to the real world scenario, you have a garden and you are growing some vegetables or some plants, whatever. You have seeds for them, and you have plants, right? So these seeds are analogous to algorithms that you have. The nutrition, the nutrient that you give, that is the data. Gardener is, and the plants are the programs. Now you can connect the dot and understand what exactly machine learning. So, in a nutshell, there are these. We have data. How do you evaluate that algorithm based on that data? And how do you optimize it to tweak certain parameters to have the output that is expected or the output that you want? Now, there are different kind of learning. Just to go through to refresh your mind. First one is the supervised one, where the training data that you give to this algorithm, it includes the desired outputs so that it can be more beneficial for the real data. Second one is unsupervised, where the training data does not include the desired outputs. Then there's a semi-supervised learning, where the training data includes desired outputs, and we use it when we don't have much data available. And the last one, and the most important one, is reinforcement learning, where there's a reward and punishment for different sets of actions. This is a figure from my own paper that we wrote back in 2020. So we classified machine learning into these classifications and looked into what kind of services could use these uh, machine learning algorithms in cyber or intelligence. There are three kinds of artificial intelligence. The first one is what we call applied AI, where it gives you a very, very specific and very sophisticated result for some very well-defined task. For example, malware detection is a very specific task, right? So if you use AI for that or applied AI for that, it will give you very specific results. Object recognition, object detection, or if you're using Apple iPhone, you know about Siri. Siri is using applied AI, okay? And it is delivered by using a very well-known machine learning technique or techniques, okay? It could use deep learning, it could use neural networks, it could use natural language processing, and so forth. So this is the basic applied AI that we have. Second one is AGI. AGI is a little bit advanced form of AI, where we have a cognitive environment, which is as good as human being, or it should learn how to do things as humans do. Imagine, how do you learn as a kid, as an adult, and as a human being? And imagine you want your computer to do the same thing as well. So this is artificial general intelligence. And the final one is strong AI, which is almost similar to applied AI, but has self-awareness as a human being. But you should keep in mind, but we are still far away from AGI and strong AI. Means that applied general intelligence and strong AI are still not achieved yet. Probably they might be in the future, but we are still far away from them. Instead, we have super AI. You might have heard of DeepMind, Google's DeepMind, MetaMind, Good AI, Blue Brain Project, and there are a lot. If you take, for example, Google's DeepMind, it is extremely, extremely sophisticated, and it even won the very famous game from a human player. So you can see this artificial intelligence is going. If we take an example, once again, machine learning is an object detection. Machine learning, I mean, machine learning is not object detection, but object detection uses machine learning. If we take the car, self-driving car, then it uses artificial intelligence as a whole, because the components that are included in autonomous car, they will be using intelligence, which is a series of different machine learning algorithms and so forth. This was not sophisticated attacks. We were involved. We use learning because of the complexity and because human intuition is extremely hard. And the changing pace of cybercrimes is also an indicator for using automated learning environments. So AI safety is the artificial intelligence plus cybersecurity, the existing mechanism. If you camouflage it with the artificial intelligence, then it will produce you the AI safety and security. If I quote Avira, they say that machine learning in security or cybersecurity is a set of programs ability to identify and block new and emerging threats, and in a very quick way. So what it does is that it has which is X data and is obtained. If this result is Y, this result is continuously updated with the new data. So data is coming and this result, and it is updated until it becomes so correct or so accurate that you don't need it anymore. It means that you're coming to an equilibrium point. Okay, and this is the basic definition of using machine learning in security. Of course, the process will be different, circumstances will be different, but still you'll be using it in the same way. And they want to focus on automation. Coming back to the sophistication in attacks, if you talk about viruses that we had in the past till 2014, let's say, more statistics are also available, but if we even look at till 2014, I'm not sure if you have heard about $2.6 billion for code. This is $8 billion for MyDo, and for the Heartbleed, it's estimated in tens of billions of dollars. Just imagine. So the need for AI is unprecedented and it's unquestionable. Imagine a service that is provided as a part of Internet of Things, smart home, where all your components or electronics, your refrigerator, your microwave oven, your air conditioner, your smart plug, your lighter, and everything are connected through internet. And imagine somebody is controlling them from outside, increasing the voltage or God knows what. It will be a catastrophic situation. So how do you safeguard against these kind of attacks? So what you need to do is to predict problems based on what? The prior solutions. And what you need to do is to use the natural language processing in order to analyze some unstructured data. Means that the data that is generated by your refrigerator, the data that is generated by your microwave oven, the data that is generated by your doors and everything, what you do is that you analyze and you look into the detailed insights to quickly, for example, stop intrusion or even prevent them in the first place. So you can see the keywords here: prediction, analysis, detailed insights, stopping, preventing, prior solutions. And all these ingredients, they come together with the help of artificial intelligence or machine learning to counter these kind of attacks. In predictive analytics, what you do is that you use anomalies in the network patterns. Remember I told you about the bank account usage? If there's anomaly then it's a red flag. It's an indicator which you will have to look more into. And it is based on behavior. Mostly in the prior solutions, what we have is, if you take example of malware, let's say, in malware, we have signatures. If today we have a malware, we analyze it and we assign a signature to it. And then tomorrow we have another malware and we compare if it is the same family or the different family. If it is the same family, then we know that this is a malware. This is not the real or benign code. But if there's no signature, then there's nothing that you can do about it. So you have to look into the behavior as well, not only signature, but the behavior. And behavior is what you, okay, the signature or the mechanism that you had before, they're static. They're just compare and see. Behavior is something that you have to learn from the previous data. So that is why you need to use the artificial intelligence and machine learning techniques. So what they do is that they learn and then use gut feeling. You know what gut feeling is in a human being as well. You just feel that something is not right. And this is what these machine learning algorithms do as well. So what might be an attack, what might not be an attack as well. Another reason is that network size is a monster, because you might be talking about huge networks. And advanced persistent threats, once again, if you talk about Stuxnet, these sophisticated attacks, Stuxnet was dormant and sitting and doing nothing in the network for, I think, months or years, actually. There's a movie, if you have watched it already, if you have not, I strongly recommend it to you. It's called 0 Days. It's not a movie, but it's a documentary, 0 Days. If you have watched it, you already know what Stuxnet did and how did it do it. And it's mind-boggling, actually, if you think about it. It's not that simple a human could think of. So you still have to come to a level, you have to bring the artificial intelligence to a level to fight against these kind of attacks. Things that we use, or the things that machine learning use, is called URL. First, you have to understand the scenario. You have to examine the mass of the data, the huge amount of data. You have to reason on that data that you have analyzed. And then you have to learn from that. So these are the three steps that are usually taken by artificial intelligence enabled security mechanisms. All these things are really good. I mean, they will serve us very well, but there's a huge problem. What is the worst phrase in cybersecurity that one could think of? It is called false positive. Whenever we talk about behavior, remember once again the example of $1 million transaction. Well, you cannot decide for sure whether it was an attack, a wrong transaction, or what. It could be a false positive. It could be a benign transaction. So false positive is something that is a great time waster and a money eater in the cybersecurity specialists or people in cybersecurity will. Why? Because it is, where do you draw a line between the normal and abnormal behavior? What transaction do you call a benign transaction, and what transaction do you call an abnormal transaction? That is the question that is not very straightforward. So usually you have true positive, means that if something is abnormal, it is predicted as abnormal. False negative means something is as normal. False positive means that something is normal, but it is predicted negative, positive, or the good things, and these two are the bad things that will wake you up entire night as a security specialist. So in false positive, if you take context into account, this could be reduced. So people are working on it, and even there are so many mechanisms that you can consider for reducing or decreasing the false positive rates, and it should be like that. I'll just go through very fast because I think I'm running out of time. What are the new trends in cybersecurity? This is from IBM, but you can take any big corporation, any big enterprise, and it will give you exactly the same idea. And these are, for example, ransomware, application development, and cybersecurity. If you're application developer, you have to think about these cybersecurity problems. Deep learning is used to detect domain generation algorithms. Means that artificial intelligence is not only used against cybersecurity, but it is used for attacks as well, which we will talk about in a moment. The fourth one is non-malware threats. So what you do is that you use the vulnerabilities that are found in web browser or some other applications. You use adaptive honeypots and honey tokens. Honeypot means a data environment where you invite the attacker. Let's suppose you create a database with a table name as passwords, okay? And then you create another table with the credit card numbers and so forth. And then you see if that is accessed by anyone. If it is accessed, it means that you're trying to cache those kind of attackers. It's a very, very insanely simple solution. And it doesn't work, by the way, because these days the attackers are so sophisticated that they can remove them. Boxing means that you put the application into a contained, controlled environment and see its behavior. What exactly does it do? Which services, for example, on Android device, it is accessing, and so forth. So you can use that as well. Okay, and there are other neural network-based solutions, but the problem is in neural networks or in deep learning, you don't know actually how this neural network works. For this, you need explainability, which we will talk about in a moment. Capsule networks, I will not go into the details of capsule networks because I think it's out of the scope here. Okay. So deep reinforcement learning, it's extremely important. For deep reinforcement learning, you do not need data. You might have heard that for machine learning, you need a lot of data, but there are some other techniques for which you don't need data. How do you train a dog? So, K9 unit, you might have if things not right, they get punishment, and so forth. So what you do by this scenario is that you put a robot in a building and tell this robot to find a warehouse by not giving any data. So by trial and error, it eventually learns about the environment and will find the warehouse. And with enough time, it can do it in a short span of time as well. Protecting the IoT is extremely important. The number of devices are humongous, and the family of devices are so huge, and the data and volume of data is so large as well. Predicting the future, this is what the online social media has been doing it as well. For example, Facebook, you believe it or not, they're doing the behavioral analysis as well. So they can even predict what you're going to do based on what you have been doing on the social media. So this is the good side of the machine learning. But if we think about adversarial machine learning, it means that the adversaries or the attackers could use the same machine learning as well. So what they do is that they could learn the approximate machine learning model, and then through interaction with that model, they can produce or they can craft or they can design certain input based on which that machine learning model fails. So this is what we call by adversarial machine learning. For example, this is a banana and this is another banana with the crafted input. So there's a sticker with this picture, and there's a pure bananas picture. If we use the classifier for this picture and this picture, by the way, this is from real world scenario, real world adversarial machine learning technique. This picture is identified as banana with 100% or 99% probability that this picture, the object in the picture is banana. But here you can see that with 99% probability, this picture is a toaster. You can see the difference. So it's just about crafting the input in a way that it misleads the machine learning model. Now you can see that what exactly can you do with this situation? It is a catastrophe. If your machine learning algorithm does this, remember the false positive, it will be a disaster. This is another one. This is a picture of panda. If you add a little bit of noise to it, then the machine learning classifier will classify this as a gibbon instead of panda with 99.3% confidence. Your machine learning or artificial intelligence algorithm is telling you that I'm 99.3% confident that this picture is a gibbon and it's not panda. Okay, so this is very much possible. Well, if you take into account the advanced behavioral attacks, then what you can do is that you can have your business email compromised. You get an email from your CFO to send some money to him, and you trust that email because the email is from your CFO. And you're suspicious and you call the CFO. If you're not having a good day, your phone might be compromised as well. And these you might think that these are very strong assumptions. Today's no, not strong assumptions at all. It's very much possible. So behavioral attacks are also possible. So machine learning itself, we use it in adversarial machine setting. We can have one pixel perturbation to fool neural network. And there's so many other examples. What is this? This is extremely important, actually. If you change only one pixel in the input image for a machine learning algorithm, you can definitely fool the neural network with it. You can use generative adversarial networks, which is, you might have heard of generative adversarial network, GANs. You have two neural networks that are competing against each other. One is generator, another one is discriminator. And they learn to differentiate the generated sample from the real sample. And they're trying to make each other fools, and they become so strong that they're not able to do that at the end of it. So in turns, it is make the learning process even stronger. So what do we have now? Well, we saw the advantages of machine learning, and we saw the downsides of machine learning, adversarial machine learning. But what conclusion do we come to? Well, we have concerns about machine learning and AI, but it's not a silver bullet. It's not going to solve all our problems. We cannot just abandon the existing techniques and start using machine learning. But the time has come that we have to live with it. So it's a cat and mouse game. You have to do the work from your end, and the adversaries will be doing from their end. So if you add or you combine the context to the application and services, then you might be able to do something which is advantageous for both the services and the enterprises. So where do we use artificial intelligence and machine learning? We use it in intrusion detection systems. We use it in authentication, authorization, DDoS, malware, eavesdropping, jamming, and there's so many other more. But the problem is, how does AI work? Well, nobody knows. Okay. No, by that I mean that in deep learning, it's usually a black box. You give it input and it gives you output, and everybody's happy. But what if you need explanation for that? Imagine a mission critical application, nuclear power plant, or healthcare where a robot is performing a surgery. If you don't know how does it work, would you be willing to risk your life with this robot? Probably you won't be. So the white box concept is extremely important. The current AI mechanism that we have, they're called black box, where you have input and you have output. You don't know what is happening inside. For that, you need explainable AI or transparent AI, or we call it interpretable AI, actually. If you imagine a heart transplant surgery by a robot, then you can imagine how important this is for your AI to be interpretable or be explainable. Or you're sitting in a driving car at the speed of 20 kilometers per hour on a Peshawar to Lahore motorway. You can imagine how serious it is to know that, or to be trusting that car with your life. Right? So it is extremely important for AI to be interpretable as well. Now, this interpretation is contextual, means that different people, the person sitting in the car, that needs different kind of explanation. The person who is developing software for that car needs a different kind of explanation. If a car stops suddenly with a sudden brake, the person sitting in the car needs to know why did it do it. For that also needs why did it do it, but based on a very technical reason, and so forth. Okay. And fairness in AI is another important issue, means that the AI has to be fair as well. Okay. If you ask some people to draw, let's say, if you ask some people to draw the picture of a shoe, and most of the people, what they did is that because of their age factor, they drew the shoes that were near to sun. So it means that the picture that was given to the AI model, they predicted as a male shoe. Why? Because most of the subjects possibly were male. That's why. So fairness in AI is also extremely important. There's another experiment that was done in Europe's conference. The people were asked, if you have a critical surgery by a robot where you have 3% chance of dying, but you cannot ask any question from robot. And the same surgery is done by a human and the doctor, and you can explain everything, but you have 15% chance of dying during that surgery. The question is, which one would you choose? Would you trust your life in a robot, or would you rather trust the explanation by a doctor? So these are the questions that you have to ask as well. So from today's talk, the takeaways are that there are lots and lots of opportunities in AI, and there are still lots of challenges, and the stakes are extremely high. What we need to do is not to reinvent the entire wheel, but make the existing wheel very efficient. Okay? So AI and ML is not only benefiting us, but it is also benefiting the attackers. So we have to think about that as well. And we have to use the expertise from both security and ML community. Some other takeaway is that AI and ML is not going to solve all our problems, and human intelligence will still prevail. We are still far away from artificial general intelligence and super intelligence. So we have to be aware of that. And last but not least, explainable AI is the future, and it's a very, very hard thing to do, but a very hot research topic as well. Thank you so much for your attendance. Now, if we have some time for questions, I think we can take some questions. Back to the organizer, please.
Okay, if anyone wants to ask any question, तो आप अपना microphone unmute कर लें, आपको allow कर दिया जाएगा access. हम अपनी side से आपको कर देंगे. आपका allow कर देंगे and then you have to toggle the button from your side.
Assalamu alaikum, sir.
Walaikum salam.
Sir, please again tell me what is malware?
Malware? Okay, malware is just a malicious code that does something that you don't want it to be doing. Okay, means that it's a malicious code that you have, for example, in your application that is trying to access the service inside your directory or a service inside your application, which is not supposed to. So it's a malicious code inside your software or your application. Is it clear?
Yes, sir. Thank you.
Assalamu alaikum. Hello, sir.
Yes.
This is Mohammad
Walaikum
Hafiz, the advisor of GCU-ACM Student Chapter. First of all, I welcome you over here on the board to discuss this very informative session with us. Thank you very much for that, for spending your precious time. My question is, what is explainable AI, and to what extent we are so far successful in explaining the AI?
Yes, a very good question. Explainable AI means that if you, I'll explain to you by an example. Well, deep learning or neural networks, they are if you remember from, I think 2-3 weeks ago or a month ago, max, I guess, Tesla self-driving car, I think hit into something and killed a person. Right? For artificial intelligence and deep learning, the entire autonomous car is based on, the entire technology is based on artificial intelligence. What made that car decide to go in that direction, for example? Of course, it has the object detection mechanism, it has the perception mechanism, it has the planning mechanism, and it has the actuation mechanism. If you want to know what made that car think, or what made that car to go in that direction and to hit into a wall or to a tree or something, if it is deep learning, it is a black box. You cannot have the deep insight, the insight to the parameters, to different layers to understand what happened. Okay, if you don't understand, then it will be very difficult to know why did it happen. Okay, your car applies brake suddenly. Okay, if it is because of some object, it's understandable. What if it does that frequently or without any reason? This is one part of the story. Second part of the story is that now we have regulations, GDPR, General Data Protection Regulation. The company or the enterprise that is using your data, they have to provide you with the reasons and with the explanation what exactly they are doing with your data. So whatever data is produced by this car, it is used by artificial intelligence inside that car. It has to be transparent and it has to be accountable. If something happens because of this data and because of the outcome of that machine learning algorithm, it has to be accountable for that. Second part of your question is that how far we are. Well, there's still, so what we try to do is the post hoc analysis. Post hoc analysis means that this thing happened and then we try to investigate it or do the forensics. The first thing which people are trying to do right now is to embed this functionality into the algorithm itself, so it can be explainable. Like if there's an artificial intelligence algorithm, if you want to make it explainable, you want to make it explainable for different stakeholders, for users, for software developers, for security architects, and for the managers, and so forth. So it's a very hard thing to do, as I said before, but it's a very interesting and very in field in research these days. I hope I made myself a little bit clear.
Sir, but as you said that these things lie on the contradictory sides. On the one side, we say that it's a black box, and on the other side, we say we want to explain it. So if we want to explain it, we have to embed some more code or some more parameters into the systems, and that
Yes,
will surely affect the performance of the system. System will be more slow.
exactly. This
Yeah. So this.
totally. So this is what research is needed for. How do you make it efficient, and how do you make it more proficient? Okay, so this is what people are working on these days. Or what you can do is that you don't make it a part of that algorithm, but you can have a parallel side of it, which is not included in the services. Okay, so there are varieties of ways to do that, but still, it's I think a very like interesting thing to consider.
It was a nice answer. One more question that is kind of more
Sure.
personal nature. What kind of problem are you are working right now? Like,
Uh, Actually, as we speak, I just submitted one paper on explainable artificial intelligence from engineering perspective. My background is from information security and privacy. I work on connected cars and autonomous cars for the last 12 or 13 years. I've been still working on, and I'm also working on the role of this cybersecurity role of artificial intelligence in cybersecurity. I've been working with the companies, for example, Royal Bank of Canada, to look into their API security platform through artificial intelligence, machine learning, and architecture security, and these kind of things I'm working on.
thank you very much, sir.
I think somebody else raised their hand. If I can see them. Yes, 0014.
Assalamu alaikum, sir.
Yes. Walaikum salam.
Sir, my question is that can we handle asymmetric and symmetric encryption using AI?
Could you please repeat your question?
Can we handle
Would you please be a little bit more elaborative by handling? What exactly do you mean by handling?
रैंसम वायरस अटैक करता है हमारे पीसी को, ठीक है, या और कुछ फाइल्स जो होती है वो डिक्रिप्ट हो जाती है। सर एक ऐसा सोल्यूशन कोई हो कि एआई के थ्रू हम इंक्रिप्ट कर ले ऑल फाइल्स, क्योंकि मेरे जो है ना पीसी को अटैक किया था तो मैं कुछ फाइल्स को इंक्रिप्ट कर पाया था और बाकी डिक्रिप्ट ही रही थी।
So AI, I think if you have to keep these things separate. Encryption algorithm, symmetric or asymmetric, I think it might have to do something with artificial intelligence, but you can just look into the behavior of what that attacker is doing or how it is encrypted. If it is encrypted with RSA, let's say RSA 2000 bit key or 4000 bit key, then you can do nothing about it unless and until you know the key. Or if it is with the AES 192 bit key, then what you can do is to I'll share it with the. I don't know where to share. Is there any place to chat here?
Sir, you can share it with our ambassador,
Okay,
with our
great,
society
great.
ambassador.
I'll do that.
So this is again a question. If somebody want to pursue MS or PhD with you, what kind of channel he can use or she can use?
So in our university, I'm the head of master program in security and network engineering. I've been running this program since 2016. There's a chance for 100% scholarships. So our university is actually totally on scholarship. Every student is on scholarship. There's no fee or nothing, but they have to fulfill the criteria. They need to be very proficient in networks. They need to know security. They need to be very proficient programming, and they need to have some industry experience as well. And on Innopolis University website is a full information about the application process and everything. Unfortunately, for this year, the applications have been finalized already because they start in November and December for this year. Because in August our new session will start. But for next year, the people who are still thinking, they can apply for the next year. So the requirements, it's not only cybersecurity, but there's a data science, there's a robotics, there's software engineering, and cybersecurity as well. So the students can select that and see the requirements for every program that is here in Innopolis University.
All right, sir. I also have a question.
Yes.
Sir, I think you discussed the white box, the essentiality of white box, and how we should understand some kind of implementations of some procedures. Do you see in the near future that we are able to trust the machines enough that we don't really need to care about the implementation, and the machine is sophisticated enough to even deal with even those procedures that we think are uh,
Well,
required?
this is a very good question, actually. This is where we are going in the future, automating automation. Okay. I just forgot. I wanted to say something. Uh, Machine doing by itself. Yes, it will happen, and it should happen actually. So trusting a machine. Yes, okay. I remember now what I was going to say. So security by obscurity. There's a phrase that we use in cybersecurity, which is what we call security by obscurity. Security by hiding something. If you have the knowledge of encryption and decryption algorithm, if you pick RSA, are you familiar with RSA or any other RSA? By any chance?
So I have a little bit of idea of the keys and stuff you discussed, but
Okay.
not in the very details because
No,
I'm
not
actually in a
detail.
very base level.
Right, but what I'm trying to say is that if you pick up any algorithm, any security algorithm, it will be crystal clear to you what are the steps that are taken by that algorithm. If you take RSA, RSA is a very, very famous industrial standard encryption, okay, technique. Everybody is using RSA throughout the world. And it is crystal clear. I can explain to you right now in the steps. What are the steps that are taken to secure the data? easier if you know what it is doing. If you know what it is doing, then I think trust will become transparent as well. So you will have to either trust it or not trust it, because you can see what exactly it is doing and which is what you wanted it to do. So I think yes, in the future, yes. But right now, we are working on the post hoc analysis or the post mortem analysis or whatever you want to call it. But yes, in the future, we will have this kind of mechanism as well.
All right, sir. Thank you. I think that answers my question.
Okay.
Sir, I have another question if you don't mind.
Sure, no problem.
Yeah. So I really don't have the very intricate ideas of the implementation of AI, but as you said, it might become sufficient. The technology might become sufficient enough that the white box implementation might not be needed later on, right? But is it possible that the AI could be tempered with, let's say, false data or something like that? It would not do the things that it was supposed to do, especially let's say in the medical fields.
We are doing that these days actually. I just
Yeah.
completed a project with my master's student. We are going to publish it. What we are trying to do, we were successful in attacking the federated learning approach, okay, where we use fake data to make fool of the federated learning algorithm, to make it classify something which was not. So it is happening as we speak, actually. But then what you have to do is that on another part, we are securing against these kind of attackers. So it's once again cat and mouse game. Adversarial artificial intelligence or adversarial learning is the same technique that I talked about, that it's used both by attackers and the good guys. So yes, the answer is yes, it's very much possible. And it's not a very sophisticated thing, actually. You can do it easily.
So what is the steps that we're taking? Like we can hide the algorithm behind an encryption or cryptography, but how are we able to defend it against a false input?
Exactly. Right. So that is why hiding it behind would be the worst idea. You never do that. What you need to do is to play with the data, remove the bias in the data, try to analyze the data so that you trust it, and then, or if you're suspicious that an attack could happen or something, then you put noise into the data, so the effect of the attack could be reduced. And controlled noise. Okay, controlled noise means that you put some garbage into the data, and you understand that garbage. So then you have a mechanism so that you can remove it later on. There are different techniques that are being used. It means that it's not that the attackers or intruders will take over the entire AI, but you have to play around and to look for techniques that would reduce the effect on the system. So it's still possible.
Right. Thank you so much, sir.
Okay, if there aren't any more questions, then I think we should be wrapping this up then. Guys, if you have any question, then you can raise your hand.
Yes, Arsalan.
Excuse me, sir. Are cyber criminals now attacking personal and corporate computers using ransomware virus again?
Yes, I think they're doing. If you look into there's specific websites actually. I didn't have time to include it here, but yes, they're doing corporate websites, and it depends on the vulnerabilities. For example, that WannaCry ransomware, it was sent, I guess, through an email or some other CVE, which is the vulnerabilities that are used that exist in operating system or some versions of a software or some version of another service, that they use those kind of vulnerabilities. So yeah, they're after it always. You have to be, you have to be sure, and you have to be very vigilant against these kind of criminals and cyber attacks. So awareness is also extremely important. You have to be aware what to do and what not to do, what sites to visit, what's not to visit, which attachments to open, which not to open, and do you have to reply to an email or you don't have to reply to an email, and what exactly do you do on internet is extremely important. So these kind of things you have to be aware of, because layman, a person on the street, they don't know about these things, right? So they're the easy target for such kind of people. So yes, it's still active. It didn't reduce. If you see the statistics, it's even increasing, but the awareness is important.
Yes, sir, thank you.
Eamon, your mic has been allowed. You can unmute it. Mohammed Ahmed, you
Sir.
can unmute your.
Sir, is there any harm from strong artificial intelligence in near future that can harmful for human, that it become more self-aware as in stronger AI is we are said that it become more self-aware, that it can make decision itself. So is there any harm from strong artificial intelligence?
I think this is a question for debate. I won't be the right person to ask that question, but I can share my personal perception with you that artificial intelligence with human, the addition of human being could do a lot of great things together. But at the same point, well, you might have seen the movie I, Robot. I'm referring to movies because that can give you a great depiction of what has been done or what has been going on in artificial intelligence. So a day might come, whether we are alive or not, in the next generation or the next to that. But I think we can do really great things with human factor in mind, because what humans have is empathy, and what artificial intelligence has is the knowledge or information. I will share an example with you. While working on autonomous cars, driverless cars, there's a very famous problem that we call trolley problem. Trolley problem goes back to the dates in 1970s. Trolley problem is something that is extremely important. What is trolley problem? Imagine you're driving your car, okay, and then there's a situation for you where either you have to hit a bus where small children are going to school or something, where you will cause the death of many people, sorry, elderly people, and on the other hand, you have another choice of hitting two people on the sidewalk of the road. One of them is children, let's say. So which one do you decide? Like, would you hit the children on the roadside, or would you hit the bus or elderly people in the bus? This is what trolley problem. Of course, there's no clear answer to that. But even for a human being, it is extremely, it's extremely complicated situation. But yet again, as a human being, we have empathy. And in some cases, even if there's something right, you won't do it because of your empathy. But for artificial intelligence, I think we are still far away from these kind of emotions and environments. So in future, it might, but I don't think it will reach the maturity of a human being. It might, but I don't see it in a very near future to be like that. So we still have a chance to use it for our advantage and for our benefits.
Okay, sir, I guess we don't have any more questions. If you would like to conclude your talk, then you can
Yes.
go ahead.
Okay. So thank you so much for inviting me. Thank you so much to the GCU-ACM Student Chapter, the organizers, especially Hamza Safdar, who was collaborating with me and talking to me and taking me through all the process. And thank you so much. And it was an honor and pleasure to be part of this event. Thank you to all organizers, and thank you to all the attendees as well. Thank you so much. Over to you, the organizer.
Okay, sir. Thank you very much for coming out here and for enlightening us with your knowledge. We've had a very useful and wonderful time here, and we shall be looking forward to more of your talks in the future. We're also grateful to the advisor of GCU-ACM Student Chapter, Mr. Mohammed Hafiz, and of course our esteemed guest speaker of the event, Dr. Rasheed Hussain, for making this event possible. And we're grateful to have you here with us today. Thank you very much, sir.
Thank you so much. I think the host will be concluding the session, I suppose.
Well, your session has been concluded,
Okay.
sir. You can,
So
you can leave if you want.
okay. Thank you so much.
Thank you.
Have a
Again,
nice
thank
day.
you again, sir.
Now, I would like to read some messages from our collaborators. At first, we have ACM concerts with WAH chapter. In ComSets WAH. We are a family of 50 members, and every individual is bright in their own way. All the events and seminars that are organized by ACM CUI WAH chapters are listed below. Executive Committee, currently Mohammed Tabish Mirza is the elected president. Aloysius Joseph Fernon is the vice president. Mariam Noon is the general secretary. Zain Hashmi is serving as director operations. Amina Batul is the treasurer. Fahad Mahmood is the current assistant secretary, and Naki Kohan is our general manager. President and vice president are elected by proper elections. Orientation. At the start of every semester, ACM CUI WAH conducts orientation session for new batch, and we guide and help them regarding the queries about the university. Seminars. Every semester, our team organizes seminars that are related to our field, and these seminars are most of the time delivered by professionals. Workshops. We also have conducted workshops in our university, also in which we mostly focus on the programs that will be beneficial for the professional life of the students. Events are FIT, VICIO Spark is the biggest event of CUIWAH as universities from all over Pakistan take part in, and this event is organized every year in fall semester by ACM CUIWAH. And in the last event before COVID, more than 450 teams from all over Pakistan actively participated in the event. In this event, many games, workshops, and seminars are organized and prizes are distributed among the winners. This event includes technical as well as non technical events. The technical events are organized by ACM CUIWH. Thank you. The next is IEEE ComCerts University Islamabad, Lahore. CUI is an unrivaled team of professionals, practitioners, and mentors that can help its students career, provide resources to develop new skills, advance their professional development, and offer several opportunities for the involvement, recognition, and reward. It IEEE CUI has been working with leading professional organizations and societies for so long, both locally and globally. Here are some of our most recent activities and collaborations. Ration Drive in Ramadan by IEEE Lahore Section, WIE, IEEE CUI Lahore and IEEE UET collaboration on APES 21, Motivational Seminar WIE Lahore Section, IEEE CUI Lahore and GCU-ACM collaboration, IEEE CUI Lahore and IEEE UET. Thank you. Last but not the least, we have IET on campus, University of Engineering and Technology, Lahore. IET on campus UET Lahore, a technical chapter affiliated with the Institution of Engineering and Technology, UK, provides a forum for people in engineering and technology domains, allowing them to empower their grasp on the technological aspects of the revolutionizing industry. Along with enhancing the literary, practical, and soft skills, this prestigious chapter of the IET gives its member a platform to improve the professional capabilities by providing constant learning opportunities. IET on campus UET Lahore has a history of collaborating with top technical organizations and communities nationally as well as internationally. Few of our recent workshops, seminars, and collaborative events are as follows. IETEC, PSSE Workshop, RoboCamp, Safety Course, Industrial Tour, Shaukat Khanam Outreach Program, Water and Air Pollution Awareness Campaign, Literary and Art Competitions, Holt Prize, DICE Virtual Innovation Competition. That will be all from our collaborators. Now, for the next webinar is Building Responsible AI Explainable and Interpretable Machine Learning Modules in Azure, AWS, and GCP. Our guest speaker is going to be Dr. Adnan Masood. Our guest is Dr. Adnan Masood. He is an artificial intelligence researcher, visiting scholar at Stanford AI Lab, software architect, Microsoft Regional Director, and MVP for Artificial Intelligence. Dr. Adnan teaches data science and has authored several data science books. So look forward to our next webinar. You can either stay as it's going to be the same link. The webinar is going to start at 3:30 p.m., so not long. Thank you for your attention, everyone. Now the attendance link is going to be shared with you in a few. So make sure to write it down on the web browser so you can fill the form. Remember